Alright, greetings. We're going to walk through the final problems not covered in class on the 18th. First one is a cost volume profit problem number 4. Anytime you see a question that says break even point, keep in mind the profit is 0 when you see break even. Two formulas that you should know. One is contribution margin ratio that we see over here times sales, that's the variable you're solving for, minus fixed cost equals profit. And again, when the question says break even, your profit is 0. The other formula is a little bit more intuitive, dealing with units. This is a pretty straightforward problem, with the toughest bit likely determining what is your contribution margin ratio. All right, and so if we jump down here, first up is get the contribution margin. Sales of 420,000 minus 147,000 of variable cost. This company has a $273,000 contribution margin. The contribution margin ratio takes that number, divides it by sales, and you get this 0.65. As we talked about previously, the way to interpret that is for every dollar of sales that you make, you effectively keep 65 cents in cash. All right, so it's going back to the formula, the 0.65 times the sales figure that we're looking for equals the 227,500 fixed cost. We got that by moving this part of the equation over here and then knowing that profit was 0. When you solve, you get 350,000, which was answer A. All right, second question is also a break-even problem. You could solve this problem with either formula, right? And so just for variety, we're going to solve it with the second formula, which is contribution margin per unit times units minus fixed cost equals profit. And again, it's break-even, so profit is 0. This one is more intuitive. Price of $35 per hour minus the $21 variable cost is where you get that $14 fixed cost per unit. Units wind up being a fraction, which is typical if you're doing a calculation. If you keep all the decimals in your calculator, you need to multiply that by $35, which is your price per unit. And the reason you need to do that is the problem asks for break even in sales dollars, right? Not in units. You get the same answer if you use the contribution margin ratio formula. All right, the next problem, also a cost volume profit. This one adds what we've called bells and whistles, right? And if you're looking at old tests, some of the bells and whistles you can add on to cost volume profit problems are things like tax rates, which you'll see on some old exams. We will not have a before tax, after tax profit problem, but we will have multiple product problems, at least one of them, and that's what this is. It's a multiple product problem. So here a company sells both X and Y. You get the ratios of those products, so they normally sell 60% X, 40% Y. And they have total fixed cost of 120,000. The key or the trick to these problems is figure out what your average unit looks like. In this case, we're really looking for the average contribution margin ratio. All right, so we have the two products, X and Y. Contribution margin ratios are given, 50% for X and 25% for Y. Multiply those by the percent of sales for each product. Add those two numbers together, this 0.3 and 0.1, and you get this story that 0.4 is your weighted average contribution margin. So if someone said, we're going to sell a product, but I'm not going to tell you which one, on average, you'll make 40 cents on the dollar for the product that you sell. Of course, you'll never actually make 40 cents. You're either going to sell product X at 50 cents or product Y at 25, but your average is 0.4. Plug that back into the contribution margin ratio formula. 0.4 times the sales dollars, which is your variable of interest, minus fixed cost equals 0. The solution is A, 30,000. All right, the next problem that we did not cover during class is from chapter 14. It's a payback period problem. This is the easiest type of problem from chapter 14. Payback period simply asks how long until you get your money back. Right, so if you put 120,000 into a coffee shop, right, that's your investment, and you expect to earn 15,000 a year. Take your investment divided by what you expect to get per year, and it'll take you 8 years to get your money back. No time value of money in a payback period problem. All right, here is a problem with time value of money. These are pretty straightforward. Again, drawing out your cash flows is probably a good thing to do on all of these problems. One thing to highlight in this problem and many old problems, and something that we'll see throughout the semester, depreciation expense is not a cash expense, right? And so if you're trying to plot out your cash flows, do not plot out depreciation. For that reason, we have a $28,000 per year cash inflow from this investment. If you spend 40 grand now, you'll get 28,000 for 4 years. Going to the table, you need a factor from the annuity table where n equals 4, I equals 14%. That factor is 2.914. Multiply it by the 28 grand. Here's something to note. Talked in class about reading carefully. This problem asks for net present value. Right, so when you do this calculation, you've actually figured out the present value of this annuity, this $28,000 per year. That number is $81,592, and you'll notice that is answer A, but that's incorrect. Right, net present value means take that money, subtract out what it cost you to get the to get those cash flows, the 40 grand, making B the correct answer. All right, we'll do one more and then cut the video in half so it doesn't get too long. Number 10 is a word problem. Right? It says a project has an internal rate of return of 14%. Increasing investment on the project will do what? And you have a bunch of options. The solution tells you that it will lower your internal rate of return. Here the timeline really helps. When you think about internal rate of return, what it's doing is equating your investment with all these future cash flows if it's an annuity, or a single cash flow if it's a simple present value problem. What the setting here says, what if you increase the initial investment? Basically they're saying, what if you made that number bigger? Right, if you made this number bigger, if you go up here, what if this was 50,000 in the prior problem? Well, your internal rate of return is lower because it took you more money to get the same return. Probably not the world's best problem. Let's go ahead and do one more to illustrate this further. This is another internal rate of return problem. It says a person invests in a project. If you give up $1,560 now, 18 years from now, you'll get $12,000. Right? So here's the picture of what's going on. Using the tables, we have this present value of 1560. With internal rate of return problems, we're actually solving for the interest rate. So we're looking for a factor where n equals 18 and I equals something. We don't know what that something is yet, but we're going to multiply that by the $12,000 payment. All right, so divide both sides of this equation by 12,000 and you get the number 0.13. All right, and let's look at how you'd go about finding that number with the table. You're actually running an algorithm. All right, so and your calculator does it too if you have a financial calculator. We know that n equals 18, so you just start looking across this row until you find a number close to 0.13, which was the number we saw for here. When you find that number, look up. All right, that's the entire algorithm. Right, so when you look up to the interest rate column, it's about a 12% interest rate. That is your internal rate of return, answer C. All right, let's stop there.